G'day there, you're watching the Aussie BIM Guru, and today you're watching the second part of my export and import family types data series. So we're looking at doing this using Dynamo, so we'll pick up where we left off. So thanks for the request again to Frank, who's been in touch with me asking if it's possible to export and import type data to families, which it is. So there's a non-Dynamo workflow available. If you're interested, I've got a video about how to use CSV files and how to manipulate family types without using Dynamo, but it's a little bit more tricky. So I've got a previous video that would have been probably released one before this, and it's just showing you how to export some family type data into Excel. What we're going to do now is re-import some updated data with new types and new data. So the workflow essentially looks a little bit like this. So we focused on this side of the workflow previously. Now we're sending our data back to Revit. And the output looked a little bit like this. So it's basically an Excel table. The header row contains the data type, which we're going to need to reprocess back into Dynamo and Revit as the right data type. The parameter name that we're pushing. The first column was always the type name, and then from there it's just respective parameters to suit. And we used the user interface originally in order to let the user pick only the parameters they want to manipulate when they create new types. Just keep in mind that we're processing data types today, so this is going to be really important in this session. So there's a whole bunch of data types available in Dynamo and Revit. There's some common ones just listed here. And it's important to note that you can't just push a number into a text field or a text into a number field, for example, or a text field into a Boolean. So we're going to need to process our data types quite carefully in order to make sure that they're read correctly when they're sent back to Revit. So there's a lot of ways to convert data types. For example, you can convert a string into a number and a number into an integer by forcing it to round to the nearest decimal place. Likewise, you can convert strings to numbers and strings to integers quite easily using these nodes as well, or converting numbers to strings. And likewise, you can convert statements to booleans just simply by checking them against a phrase. We're going to be using some custom nodes today. So we're going to be using 3 nodes from the Orchid package in order to open a family, load families, and close the family as well. It's really important to note that this is going to be a background process in Revit. So we're actually going to be able to open our family, manipulate its data, and close it without actually a need to do it ourselves, which is really cool. So we're using Dynamo 2.0.3 today. Ideally, just anything in the 2.0 should probably work for this. Haven't tested this in 2.1 for people in 2020. So if you do test this, let me know how it goes. So without further ado, let's just jump into where we were left off in the last tutorial. So we've got a family here, so basically just an underbench cupboard family with 2 types. So there's one that's a custom size 2-door family and one that has a fixed size. Note that these are called 2 doors. So what I've actually done is taken the door off this family in the parameters because I want to actually validate that data that I modify within Excel will update existing types as well. So I've actually set the type data incorrectly, and we'll fix this in Excel. So I've got my Excel table here, and I've just grayed out the rows that contain existing types. So I've actually intentionally put the types in different locations. So you can see I've put one at the front of the list and one at the back of the list. And this is just to make sure that when I manipulate and reintroduce this type data, the script can handle existing types and new types being in any position in the Excel table. So that's why I've done this. But otherwise, all these things in here are whole new types. So we've got some 1-door cupboards, some 2-door cupboards, some open cupboards, all being controlled by a parameter, which is an integer that controls the number of doors. But we have a whole bunch of other things as well, like we have some glazed door parameters as well, which is a Boolean. We have some material parameters as well, so we'll need to process Revit materials. And we have some dimension parameters, which are doubles or numbers. And then also just a description in text and a code in text and a type name, of course. So we're going to process this through Dynamo and reintroduce some new types to the family and pick up any changes that are detected in the new type data. So let's just jump back into Revit and we'll jump straight into Dynamo. So we're going to start off by interpreting our Excel file. So we need to get an import Excel node to do this. Note that I'm in manual mode as well. You definitely want to make sure you're in manual mode. So we're going to get a file path and a file from path, or a file from file path, just to get our Excel data. So I'm just going to path to where I've located that data, and I'll just load in this table. And you'll need to put in just a little bit of data. So what is the sheet called? In my case, it's called sheet 1. Now we do want to read as strings. I'm going to turn everything into text because I don't want Excel to have the ability to interpret what the data type should be. because it might get it wrong. So I'd rather just treat everything as text until I process my data types, and we won't show Excel. So I'll just close my Excel file. Okay, so at that point we can basically export our data. So if I run this, we'll get our Excel data, and it should be in sublists by row. So you can see that our first row, which is our data type, is our first sublist. Our second row is our parameter name, which is again the next sublist, and from there it's just rows of information per type. So the first thing we're going to do is we're going to drop the first two rows. So that's our data type and our parameter names. So we're just going to get a drop items node, and we're just going to drop the first two items. Keep in mind we are going to keep these items in a different data stream so that we can handle the parameter names and the data type separately. So we're going to take that and lose our top two rows. And then from there, we're going to run a get item at index node. And essentially we're just trying to get our type names. It's important to note that our type names occur in the first index of every sublist. So we're going to work at level 2, and we're going to get the item at index 0 from each sublist using levels. So this should give us just a single list of all our type names. So a really easy way to extract a column out of a set of rows using levels. What we need to do now is get our family type, which we're actually comparing. So we'll actually get a families drop down instead, because we don't want to just get one type. We want to get the overall family, and we want to identify all of its types. So we're going to feed in a family types node to find all the types. Sorry, not that one. It's actually a node that should list all the available types. There we go, family.types. So if I run this, we'll have two types. Let's say that we had an extra type that isn't relevant to the family. So let's just introduce that now while it's still early. So I would just duplicate one of these types, and I'll just call this rogue type, because essentially we want to have the ability to not have to get interrupted by a type that doesn't occur in our type table. Because sometimes you might not extract every type, or the family might get updated in the meantime. So if I just rerun this and get all my family types again, I'll just disconnect and reconnect. Now we have that rogue type which doesn't occur. So we're going to get the type name. So we'll just use element name and get the name of each of those types. And essentially we want to check if these occur in our Excel list of types. So we're going to run a list contains node. And we're going to be checking if this list at level 2 contains these items. So we're going to run a check, and we'll lace it as longest as well, so that we check every item whether it occurs in the list. And we can see that at the moment, actually, we need to double check if this type exists at level 2, I believe. There we go. So instead we're actually checking if at level 2 to each of these respective types exist. So now we can see that those two do exist, but this rogue type doesn't exist in Excel. So we're going to filter this out using a Boolean mask. So we're going to filter based on this mask, and we're going to filter out by our type name, and we're also going to filter our types themselves. So we'll get another mask and we'll filter the family types as well. And this should leave us with an in list that represents our two types by name and our two actual family types as well. Okay, so probably the next best thing we can do from here is just start extracting some of our data from our Excel file that we're going to process. So the first thing we'll do is we'll extrapolate the top two items into a code block. So we'll just say that the data type as a variable equals index 0 of our Excel table, so our first sublist. And then we'll say our parameter name, and you can call these whatever you want, equals the item at index 1. So now if I run this, we'll break those two sublists into two outputs. We'll only see the bottom output because it's in a code block, but essentially both sublists will look a little bit like that. Okay. After that, we need to check the index of these types in our type list. So we're going to take our resultant output over here and check which index of the list of type names from Excel these occur in. This way we can extrapolate the values as well. So we're going to check, I believe we're checking back at our get item at index. Okay, because this is our list of type names, so we want to know which indices these occur at. So we know that they occur at the first and the last index. And there you go, we can see our first and our last index. So from there, we actually need to get the values of those. So we're going to get items at index. So we're going to use a get item at index node. And then from our values minus our headers, we need to find those values. Okay, so we should end up with two sublists that represent our two sets of parameters, essentially. Although I think these ones are before our drop item. Okay, that might not quite be correct. I'm just working with a reference script at the moment just to make sure I stay on course. I'll just double check that that's correct. In fact, I believe that is correct by the looks of it. So we have our description and our code. Although it looks like it hasn't dropped the two items at the front of my list, which is quite interesting. We dropped them later. Okay, so we're going to drop these type names later on in our scripts because we are going to have to manage those out because they already have a type name. Okay, but we'll take this and we'll move this closer because this is going to be basically a gate of data at this point that we're moving beyond. Okay, so we're going to remove items at indices. So we're going to also have to drop a couple of elements from that list as well. So we're going to drop those values and get our remaining type data for our new types as well. So this will be everything except for those two types as well. So you can notice that now we bypass the first and the last item of our list and they're removed. So we have our new type data and our existing type data. It's important to note that the order that the family types occur within the family may not be in the same order as they appear in Excel. So we need to actually rearrange our types as well based on their indices, because it could be index 11 and index 0 instead, for example, in the order they occur in. So we use sort by key to do that, because our indices are a number, so we can sort based on this number. So we're going to be sorting our two types based on the keys, which are their indices. So if this was 11 and 0, it would actually invert 11 and 0. But their type data is okay, because their type data appears in the order that it appears in Excel. So we only need to do this to invert our types. So now if we run this, we'll get a sorted list and sorted keys. In this case, they didn't flip, but in some cases they would. Okay, so now we have a whole bunch of data to proceed onwards with. If you're wondering about when we're going to create existing types, we're going to do that right at the end, because that step is really crucial to running the script. So we don't want to have to rerun that process, but we'll keep processing our data for now. So it gets a little bit tricky now. So we're going to have to drop a few items. So you'll note that in our data type list and our parameter name list, we still have type name. So we don't want type name. We're going to remove this because we know how to deal with our type names. Likewise, we're going to be getting rid of the type name from these lists as well. So we're going to be dropping some items. So we're going to get a drop item at index list. So drop items, and we're going to be dropping the first item of a few lists. So the first list is the data type. Our second list is going to be our parameter names. There's probably some more efficient ways to do this, but I found that this is at least the easiest way to teach this process. And then we're going to need to drop the first item in every sublist in here, which is basically the type data. So we're going to take another list and we're going to feed in this whole set of sublists. But like before, we're actually going to work at level 2 in order to work in every single sublist. So essentially we'll end up with the same list without the first item of each sublist. So we successfully processed out our type value. What we need to do now is transpose our new values. So what I need to actually do is take this list, sorry, my existing values. These are our, sorry, no. Is that correct? I'll just cross-check that I've got this correct again. Index. Okay, I think that's correct. So this is correct for now. So what we're doing is maintaining the structure of our existing type data, sorry, our new type data, and then we're going to process our new values differently to our existing values. So this should be our existing values. Yes, so this is our pre-existing type data. This is our new type data. So what we need to do now is actually transpose all of our new type data, because we're going to process a little bit differently for this set of data. Sorry, some of this will start to make sense soon. It's a little bit of a complicated step in the script, so just follow along with the nodes that I'm building, and I'll try to explain the data flow as I go through. Okay, so we're going to drop from each of these lists. Note that these have become sublists based on the values of the parameters, so we just need to drop the first sublist in this case. So we're going to drop one item, and effectively we've managed out our type values, and each remaining sublist is the parameter values that we're going to introduce to our new types. We will reintroduce our existing parameter types as well later on in the script, but at the moment we essentially have a list that represents the data type for each of these sublists, the parameter names, the existing values to be populated, and the new values to be populated. So we can proceed forward with this data now quite easily. We're going to go and set up just a small node over here for later to get the new type names. So we're going to get item at index, and we're going to be working at level 2, and we're going to be working out of our new values, and we're going to get items at index 0. Okay, so if I run this, there you go. We'll get a list of type values. I could use a filter by Boolean mask up here instead, just to split the list, or a list split node, but I find it easier to separate the data at this point for the user. But if you're building efficiently, there's some more efficient ways to build this section of the script. Okay, and we'll use this data later on. What we need to do now is start processing our values in order to build a list of values, a list of parameters, and an equal list of family types to push data into. So the first thing we're going to do is we're going to transpose this list. So we'll just get a transpose node so that we can get all our existing values, because we need to append these to the front of each of the sublists in our other transposed list. So we're going to use list combine in order to run a function across these two lists. So we want to join each of these lists together one by one. So we're going to run a join function with two lists as our combinator, and then we're going to run our transpose list over our new values. And essentially what this should do is attach the existing values to the front of each sublist respectively. So now we've combined all our data together, which is a really important step. So the list combine node is really helpful for running functions at the same level across multiple lists. Okay, so what we're going to do now is we're going to start processing some of our data. So we're going to use a pretty big code block to do this. I've had users request code blocks in my scripts more often, so I will introduce them here and there and explain how I'm using them to save a bit of time. So the first thing we're going to do is process our materials. So remember that every single piece of data at the moment is just text. So we need to start processing our data into other data types and then extract the relevant sublists as the right types based on the data type from our Excel file. So the first thing we're going to do is process our materials. So I'm just going to feed in all my data and get material by name. And we'll get some nulls. Some things won't be materials by name, but some things will. So you can see it's found a match for our material parameter values. So that's really important. So that's our first element converted. What I'm going to do now is build up a code block. So I'm going to take all my strings as one output. I'm going to find all my doubles. And I'm just going to write a little function that's going to look for, basically a list where we're going to convert strings to numbers, and we're going to convert our list of strings. So if at this point I feed in my string list, we'll end up with two outputs. We're going to get some errors because not everything can be converted to a string. So currently this script will give you a bunch of errors. Hopefully you can handle those. If not, there's probably ways around it. But you'll see at the moment that one of our sublists here is anything that can be converted to a number from strings has now been converted to a number. We're going to keep going with this logic, and we're going to make a integer list as well, and we're going to use the function dscore math floor. So we're going to apply a floor function. You can use nodes to do all of these, and we're going to apply it to the double list. Likewise, we're just going to check where string is equal to true in order to get a list of trues and falses based on our Boolean lists. You can see there that this last one that we're seeing will just give us a whole bunch of trues, falses, and where there is no trues or falses, we'll just get straight falses. So what we're going to do is combine this into a big list. So we're going to use this to basically cherry pick the respective sublists to get all our data formatted properly. So we're going to get 5 sublists, and we're going to get first our strings, and then we're going to get our materials, numbers, integers, and booleans. And we'll end up with a really big list of lists. So essentially we're going to get a lot of stuff in this list. We'll get our list of everything as strings, we'll get our list of everything as materials, so on and so forth. Obviously this isn't appropriate yet. We have far too many pieces of data here. We only want one sublist from each of those lists. So we're going to run another code block at this point to detect the right indice to obtain these lists from in order to put our data back together. So we're going to build a big if code block at this point to detect what indices we should be using. So we're going to use our data list as an input. So back here we have a list of our data types at each respective list index. So you can see we have strings, doubles, booleans, integers, and materials. So I'm going to connect this up to a code block, and I'm just going to call it x that we're analyzing. And I'll say if x equals to material, and then we'll use a question mark to imply an if statement. We'll say 1. At this point we could just say otherwise 2. This would say if material, give me 1 out of here, otherwise give me 2. But we're going to start nesting if statements. So we're going to say otherwise if x equals to double, then we'll return 2. Otherwise if x equals to integer 64, which is an integer, gives me 3. Otherwise if x is equal to boolean, give me 4, otherwise give me 5. Give me 5. Cool, so you see that these correlate to the order that I've fed these lists in, essentially. Well, they're actually, sorry, not 5, 0. So if I'm going to get a sublist from index 0, it's obviously just my strings on my basic list with no formatting applied to it. Otherwise it will be material, double, integer, and boolean. So we're going to use this to map our data, essentially. So I'm going to go back and connect that up to my data types, and I'll essentially get a list of numbers that we should be extracting our values from. So if I run this, I'll get a list of the 13 respective data types we should be pulling our values from. Okay, so at this point, I'm going to run get item at index. And I'm just going to get each index from this big list. And for now, that's not going to be correct, because we still have all the non-correlating data types within each of those lists as extra sublists. So we need to only get the index of each of those lists to get the sublist that matters in each one. So again, we're going to run a list combine function. So the first thing I need to do is I need to count how many things I'm dealing with, or how many respective parameters I'm handling, and then get the number of indices as a range. So I'm going to go 0 through to x minus 1 through to 1. And I'll get a list of these indexes from 0 through to 12. So depending on the number of parameters I'm dealing with, I'll get a list of each of those. And the reason we're doing that is we're going to run another list combine function. So I'm just going to say that we're running a get item at index node. So within each list, we're going to be extracting an index. So I'm just going to say get item at index is my combinator. And so from each sublist within this big list of lists, we're only going to get the index that relates to each list as it occurs. So at index 1, I'll get sublist 1, at index 2, I'll get sublist 2, etc. Now if I run that, we'll get the true and correct data types formatted in sublists. So now we have our materials as materials, our booleans as booleans, numbers as numbers, text as text, and doubles as doubles. So really powerful. We've just extracted a lot of data types and formatted a lot of data. Quite complicated, but we got there in the end. So this is pretty much where we're going to go back and start working with other values in order to actually create family types and feed in data. So I'm just going to flatten this big list, because really at the end of our script, we're aiming for a set parameter by name node. So we have, at the moment, our values, but we don't have our elements and we don't have our parameter names either. So this is where things are going to get a little bit tricky. So bear with me. We're going to go for quite a while in the script without running anything. But essentially, we're going to get to a point where we can load all our families, make all the new types, and then carry through our types to the end of our script. So just bear with me and try to follow along. I can always send you the script as well, obviously, if this is all too complicated, but hopefully it will be a fun little challenge for everyone. So remember that we had a list of our types to be created back here, in the order they appear in Excel. So we're going to go back to our family, and we're actually going to go and obtain its family document from Orchid. So I might just cross-check. Yes, this is the Orchid node. Cool. So what this node does is it actually opens the family in the background. So you won't see it open, but it will open. So it's just family document, open family document. So it's going to find this family in your project, and it will open the file in the background so we can add new types to it. Which is quite a strange thing when you think about it, because we're so used to seeing things when we open them. So it's actually quite exciting. I think it's a really interesting function that we've come across here. Okay, so what we need to do now is start building a method to add types to our family. So the first thing we're going to do is do family type create from Orchid. So I'll just go find that. Create family type from Orchid. So this needs family types, or a family document, and a name. We're going to lace as longest so that for one family we make multiple types. So we're going to take our family document and we're going to connect this back up to our list of family types here. So essentially at this point this would create a whole list of family types, but it wouldn't load it back into the project. So it's still storing it in the background, which is why I'm not running the script yet, because that can be quite confusing. Okay, so what we need to do is start setting up some stages for our data to wait for things. So I do want to load the family back into my project, but not until I've created new types. So we're going to create a pass-through node. So we're going to do a square bracket, pass-through, wait for, and then we're going to create a index of 0. So the way that the script works is there's a pass-through input and a wait for input, and this syntax lets the script know to wait for something before you pass something else through, and then there's just one output on the end. Okay, so we're going to be passing through our family document, but we're going to be waiting until we've added new types before we load. You may not need some of these pass-throughs, but I like to use them just to have confidence that everything happens in order. So we're going to do a document load family after that. So I'll just find the load family node. There we go, load family. Okay, so we're gonna load the family that comes through from pass-through to family document. Then we're going to close our document, which is going to be our family document. But again, we need to wait until our family's been loaded before we close it. So we're going to pass through our family document again, but we're going to wait until we've loaded our family. And then we're going to use a document close node from Orchid. So we'll close the document and we will set the boolean to false. We don't want to save the document, we're just loading it back into our project. This will essentially add the types, load the family, close the family, and you'll never see it happen basically. So quite interesting. Once this has happened, then we can set up another pass-through, wait until our document is closed, and we're going to be feeding through our family name again. So I found that if you don't feed through your family name again, if you try to obtain it from all the way back here, Dynamo doesn't understand what you're trying to do. So what I'll do here is just get a family name node to get the name of our original family, which Dynamo can hold on to from what I found. So we're going to take that and we're going to carry this through till after we've processed our family and pass it through. And the reason we're doing this is that we need to grab all of our family types once we have new family types available. Okay. So keep in mind you'll have your existing family types and you'll have your new family types as well. So what we need to do is get family by name. Cool. Okay, so we need to get family type by family and name. Family type by family and name. Okay, so from this family that we're passing through, we need to get all of our types we've just created. So we're going to go back and get our family type names. And I found that this will actually obtain the types once they've been created. So it's a little bit complicated. And essentially we need to add these items on the front, or we need to add our existing types to the front of this list as well. So I'm going to get an add item to front. I would run this to show you the data stream, but unfortunately it won't work more than once because I'm going to be loading the family, obviously. So what I'm going to do is load my existing family types back here. So this is my sorted list where we sorted our types by their keys as they appear in Excel. So now we'll have our two existing types added to the front of all our new types. Okay, and then we'll flatten this list. So we're almost done at this point and ready to run, and then I'll show the data stream in action. Okay, so the last thing we need to do is actually cycle our outcomes. So for every parameter, we need a family, and for every family, we need a parameter in that order. So we're going to do a couple of counts. So we're going to count the number of types that we're dealing with, and we're also going to count the number of parameters that we're dealing with as well. So we'll count our types, and we're also going to count the number of parameters we're handling back here. So our parameters should be here. There we go, that's all our parameter names. So now we know how many parameters we're dealing with, but also how many family types we're dealing with. And we need to build an equal list that is in the order of our parameter values, which is really important. So our parameter values occur in the order of each type, one parameter at a time. So what we're going to need to do is cycle these lists in order to effectively prepare them to be in the same order as our parameter values. So we're going to use a list cycle. I'm trying to think if there's an easy way to actually run this script more than just once. I don't think there is, so just bear with me. Okay, so we're going to take all of our parameters back here, and we're going to create a cycled list for each of these. So we're essentially going to be creating I need to connect that up first. Taking our parameters and cycling them for each type that we have. Okay, and we're going to be cycling them at level 1. So we're going to, for each type, each parameter, we're going to create that many copies of it in a row. So we're going to be feeding through our count in this case, and the count is going to be how many types we have. And then we'll be flattening the output. So you'll see the outcome of this in a second. So if it doesn't make sense, don't worry, I'll show it all in action. And essentially these will be our parameter names at this point. And our elements are our family types. This one's a little bit easier. So we don't need to cycle at level 1 because we'll have a list of family types that we just want to keep repeating over and over again for each parameter value. So we're saying for each parameter with this value for this type, set the parameter. Okay, so at this point we're going to be taking our list of types and we're going to be cycling them by the number of parameters they have instead, flattening the output and setting the element. So at this point our script is complete, so I'm going to run it in Dynamo and show you how it's set up. So I'll just open up my script again. So essentially I'll just run this with my families open on the side so you can see their family values update. So essentially we've picked our family back here, and that's really our only input, our family and our Excel file. So if you were in Dynamo Player, I'd make that an input, and I'd make the family type an input as well. Okay, so let's run this, and fingers crossed it works first time. Run. You should see these gain a couple of doors if this worked. Okay, it didn't work. I'll quickly just check why. So we've hit a bit of a roadblock here. So we're passing through our family name, family type by name. Okay. So I think that's where I've made an error. I need to feed through a family by name. That's why. So I need to go family by name, using the family name, then feed that through as a family. So that's the mistake I've made. So I'll just close my script, and I'll just, you can see that all our types got created, which is great, but I'll just undo to before our types got created. Okay, so I'll just try running that again now that I've fed through the family as a family to that node, and hopefully it works this time. I believe that's the only error that I made. So we should see these update ideally. Fingers crossed. It's a complex script, so, oh, it worked. There we go. Cool. So essentially these have had their parameters updated from Excel, which is great, by type. So ideally you shouldn't see any warnings up to the end of your script. If you have any parameters locked down by formulas, they'll give you a null. They'll still try to set themselves anyway, but they'll fail. But essentially, I'm just going to review the data flow a little bit in a second, but I'll just show you first that these worked. So let's just look at one of the new types that came through. So you can see that all our types are here now. Let's look at a glass door type, a one door glass door. And there you go. You can see all those values I've tried to push through have come through successfully. The door knows that it's glass. It knows its size. It knows that it's one door. We can look at a 0 door, so an open cupboard with no doors and a different size. And you can see that's come through as well. So that's great. The script has worked. So if I just go back in Dynamo and have a look at the data stream, just to explain how some of this works. And I go back here, you can see that we've got our family document. Here we've been looking at our existing types. We're taking our family name through for later in the script. We've got our new types, or our names for our new types. So we're creating a new type in that family. We're waiting. Then we're loading that one family. You can see it says family loaded. We're waiting. We're closing. So you can see document closed. We're waiting. We're getting our family by name from our pass-through that goes back to the start of our script and gets the family name, and then we're getting our types from that family respectively. From there, we're adding our existing types on the front, but notice how they're sitting at a different level. So that's why we flatten, in order to get all our types sitting at the same level. I'll just run through the cycling because that's quite important. So I've checked how many families I have and how many parameters I'm applying to them. Because when we've got all our data, we just have a massive list of data in the order of the parameters we want to apply type by type. So what we need to do is cycle to get a whole bunch of sublists for each parameter. Because essentially we're setting each type in order. So we're going type 1, parameter 1, set this, type 2, parameter 1, set this. So we cycle this to get a whole list of parameters in the same order as our parameter values we're applying. But it's different for our families. So here we have a list of family types instead. And we don't want to cycle them the same way. We want to cycle them without working at levels by the number of parameters we have. So you'll see now we just have an ongoing list of types. So we don't actually even need to flatten our output here technically. But you can see now that we have our types occurring in order, repeating by the number of parameters we're applying. So this is how you can apply those 3 sets of data at the end of your script. So a really powerful workflow, all in all. You will get a couple of warnings in the middle, where we've set some of those parameters that don't have a valid conversion. But otherwise, the script should work. Obviously, a really big script, so thanks for persevering if you watch the whole thing. And hopefully you've tried and tested this at home as well. Highly recommend it. It's a really useful script. So that's how you do it. So you could make some more aspects of the script. One really important thing to add, I think, is the ability to understand when there's no new types detected in the Excel file, but you still want to update parameter values of existing types. So you'll need to find a way to catch and handle this scenario by identifying some null lists that have nothing in them for the new types and reroute your data using an if function. It's a little bit complicated, so feel free to reach out on my email if you're interested in trying this out. Likewise, you could also set up the script so that your export has a value that says what is your existing type name and what is your new type name, in case you want to rename an existing type to suit some parameters you've changed. So for example, if you change the size of a cupboard and the size of the cupboard is also in the name of your type, you might want to actually change the type name as well. This is quite complicated, but possible again. So thanks for watching today. I know that's probably quite a long and difficult tutorial to get through, but I hope that it helped people out that were asking for this one. If you're not already following and subscribing, feel free to do so, and don't hesitate to reach out through my comments or email. I'm always happy to take on requests or just help people out with their Dynamo scripting. Hopefully I'll see you in the next video. Thanks. Take care.